Here's our last video review covering questions 8, 9, and 10. Question 8 asks us to differentiate using the product rule. And the first thing that we need to do, I feel, is to identify what are the two factors of the product. That is, what two functions multiplied together give us this function we're differentiating. So the first function is clearly x to the fourth, and the second e to the x. So we label f of x, x to the fourth, and g of x, e to the x, and then we differentiate each of those. I really recommend that you put together a little legend or a chart like this where you have these four labeled so that you can then insert them in order to create your derivative. So the f of x is x to the fourth. We just use the power rule to differentiate that to get its derivative, bring the 4 around front, and subtract 1 from this 4, so the derivative of that term or that function is 4x cubed. Now g of x being e of x is simple to differentiate because it is, as we said, the only function which is its own derivative. So g of x is e to the x, g prime of x, or d dx of e to the x is e to the x. Now we put these into our formula, f prime g plus f g prime, and so f prime of x, or not, yeah, f prime of x is 4x cubed, so that's the first factor we write down. And the second is going to be the g of x, which is e to the x. And then plus we add to that f of x, or just f, which is x to the fourth, and g prime of x, or the derivative of g of x, which is just e to the x. So our derivative is 4x cubed times e to the x plus x to the fourth times e to the x. That answer's fine with me, but if you want to factor out the greatest common factor, there is an e to the x in both terms, and there's an x cubed in both terms. Now there's an x cubed here. X to the fourth is x times x cubed, so you would leave an x inside the parentheses and factor out the x cubed. So either of these two ways of representing the derivative is going to be just fine. Now the next question, number 9, asks us to use the quotient rule. And we do a similar thing to what we just did in differentiating using the product rule. That is to say, we identify the f and the g, and then differentiate each, and put them in this little chart here to keep them straight, to keep them organized. The f of x in a quotient like this is the numerator, so f of x is equal to x, and the denominator here is just 2 minus x, so the denominator is 2 minus x, that's g of x. Then we differentiate each. Well, the derivative of x is just 1. Excuse me, the derivative of 2 minus x is negative 1 because the 2 differentiates to 0 since it's a constant. And the x, being a linear term that is raised to the first power, means that we just, it differentiates to just whatever its coefficient is. And its coefficient is just negative 1. So there are the f, the g, and the f prime and the g prime. Excuse me, and we symbol those now in using our formula. So f prime is just 1. And we multiply that times g, or g of x, which is 2 minus x. And we want to be careful to put parentheses around our function if it has more than one term. And that's what we have here. 2 minus x is 2 terms, so we want to have parentheses around that and multiply the f prime, which is just 1, so it's not actually going to make a difference. But it could if the derivative, if this function was, let's say, 2x, then our derivative would be 2, and it would be very important to make sure that we have parentheses around these two terms, because then the 2 would distribute here. But that's not the case here. Just a word of warning to look out for on your exam. Excuse me. And then we subtract the f of x, and f of x is x, and g prime is -1. So this is minus x times -1. Well, when we distribute this 1, well, that just gives us 2 minus x. And negative x times -1 gives us a positive x. So in our numerator, we have 2 minus x plus x, so our numerator of the derivative is just 2. And then in the denominator, all we have to do is just put some parentheses around our g of x and square it. So our derivative ends up being 2 over the quantity 2 minus x squared. The quantity being the math way of saying inside some parentheses. And the last question asks us to differentiate using the chain rule. And I'll just talk through it the way I think of this. If you want to use the u substitution, then you can follow the examples that we did in class on Monday, and I believe we did this very example in class on Monday, but I'll run through it again. Excuse me. So in order to differentiate using the chain rule, we need to determine, we need to be able to see what's the inside function, what's the outside function. What's inside here? Well, inside of some quantity raised to the 4th power is x minus 2 times the natural log of x. So that's what's inside the parentheses, and that's the function inside. Well, differentiate the outside first and leave what's inside alone. Then differentiate the inside. Well, to differentiate what's outside, we just use the power rule, because this is raised to the 4th power. We bring the 4 around front of these parentheses, and we subtract 1 from the 4, so this becomes 4 times this function in parentheses raised to the 3rd. Then we differentiate what's inside. We don't pay any attention to the 4 and the 3. We just look what's inside the parentheses. And since this first term of that inner function is x, then that differentiates to 1. And the second one, the second term is minus 2 natural log of x, so we know that the natural log of x differentiates as 1 over x. Well, 2 times 1 over x is 2 over x. So the derivative of the inside of these parentheses becomes 1 minus 2 over x. Now, the only simplification that makes any sense for us to do here is to multiply this 4 times these terms here. We can't really multiply that 4 times these terms here because they're cubed. They're raised to the 3rd power. We could do that. We'd get really messy, and we'd have terms all over the paper, and maybe barely enough room to even write them, depending upon how large you write. But that's all I did here. As I said, I just multiplied the 4 times these terms. 4 times 1 is 4, and 4 times 2 over x is 8 over x, and I left this in this form here. And so that concludes the video review for the exam proper. There is a bonus question, and I may or may not have something to say in another review video for that, but if I do, that'll be later in the day. This will conclude the review videos for now. As always, text me, email me, or call me if you have questions.